Uh, Dear students, last class we have discussed about the helical gear design procedures, and we have also solved some of the problems in spur gear. And we have come across that the differences between the two helical gears, design of helical gears as well as the design of spur gear. Both the steps and procedures are same for helical as well as the spur gear. Only differences is you can find some of the formulas, the differences in the formula. Otherwise, remaining all the things are very common. So let us discuss how many types of problem, that what are the differences you have to find out, how many types of problem can see it in the helical as well as in the spur gear. I'll take the example of helical gears today. The type 1 problem says that here the number of teeth will be given in the question. I repeat, the number of teeth will be given in the question. So there is an example like this. We read this question: design a pair of helical gear to transmit 12 kilowatts at 1200 rpm of pinion. The velocity ratio is 3 to 1. Pinion has 24 teeth. Remember, note this, there are the number of teeth, that is z value is given. Pinion z1 value is given in the question and made up of 0.4% carbon steel, untreated. The gear is made up of cast iron, 14 and of involute. Pressure angle, helix angle is 25 degrees Celsius. So in this question you can note the number of teeth or z1 value is given in the question. So you can easily find out z2, and you can easily velocity ratio is given, high value is given, so you can easily calculate the remaining procedures as commonly there is no much, there is no complication in this question. This is a direct type of question. Okay, remember this. So nothing to worry about this. If you find this question, follow the same steps, procedures, and you can complete that. So you can solve the questions or you can design the helical gear. Okay, next, type 2 question. This is a very important question. Type 2 question: the pitch dia given, means d value will be given, pitch dia will be given, and number of teeth is not given. Remember, type 2, pitch dia is given, d value, number of teeth is not given. Example, how it will the question? Let us see one type. Example: design a pair of helical gear to transmit 30 kilowatts at 1300 rpm of cast steel pinion. The transmission ratio is 5. Helix angle is 25 degree. Minimum pitch dia, underline this, minimum pitch dia of any gear should not be less than 125 mm. See, the d1 value or d value will be given, d2, d1 is 125 mm is given, and remaining thing 14 and half involute. Gear is made up of high grade material, part is given, material type is given. In this question, nowhere the z value, the number of teeth of pinion or gear is not given, only the pitch dia is given. In this case, what you have to find out: first, note down the given things in order and calculate what are the necessary things from these things, basic things. That is, see, the d1 is given, so there is a formula, I is equal to ratio of diameters. From this you can find out d2 also, because in d1 no, d2 you can automatically you can find. It's like this formula, I is equal to d2 by d1, so I is equal to d2 by d1, or d2 is equal to I into d1, that you can find out. Next, see if that number of teeth is not given, how to solve this? Next, assume temporarily you have to assume the z1 value is 20 teeth. Z1 value is 20 teeth. You cannot take 21, 22, something like this, because 20 is also standard value from the module standard number of teeth. You can assume 20 z1 temporarily for the temporary time. Then afterwards, after certain types, one or second step, you need to find actual number of z value, I mean actual number of teeth in the later stage. For time being, for temporarily assume z1 is 20 teeth to identify the weaker member. So when you assume z1 is equal to 20, we know the I value is 5, so we can find out I to z2 value, that becomes z. You can find out the number of teeth of z2 also. Next, the important procedures are important. One of the steps in the helical gear is you need to find out virtual teeth, that is zv, z1v. There is a formula for this. We know this, we have assumed this value, so that you have find out z1 value and z2v value. We got it some values here. Similarly, from the Lewis form factor, y1 value, y2 value you can find out. because we know that z1 zv value and z2 value, z1v value and z2v value, right? These are all, this will go as per the procedure. Once you assume it, this number of teeth. Remember, after later stage, you need to find out the exact number of teeth. This is the assumed value. So after certain steps, you need to find the real value of it. Let us see here. Step number 1, as usual, identify the weaker member. Since we know the material part, since we have gear and pinion, and we know the values of y, because the Lewis form factor we already found it in the last step. That is here from this part. We know this. Okay, we know this material guy grade steel, and remaining part cast steel pinion. So based on that, we got these values. We know these y values. When you multiply, you will get it. So since this is a lesser value, we will consider gear is the weaker member, and we will design it based on the gear. Okay. Next, as per the next step, tangential tooth, there is a formula here. You find out this, you substitute the value, you will get it. That is called equation 1. Next, again one more step, that is Lewis equation tangential tooth load. That is Ft is equal to sigma b into y into Pn into Kv divided by Cv. All the things are given. Remember, in this Lewis form factor, Lewis equation of tangential tooth load, sigma value will be given because it is already known from the data table. B value is equal to 10 times the Mn, that is also standard value. Y2 is equal to, since it is gear design, I take Y2 value. Since it is pinion is weaker, then I could have taken this Y1. So here weaker member is the gear, so I will go for Y2. Y2 is equal to 0.124 minus 0.684 divided by Z2V. Dear students, remember this formula again is in the again you can see the Z2 virtual number. Again we already assumed the value of number of teeth. This is not actual value. This is not actual number of teeth. Only the assumption. Based on the assumption we got it. So we need to remove this z term in the equation. So for this there is a one formula. Wherever there is a z1 value, there is a z1, wherever there you find a z1 value, there is a one formula. Z is equal to d cos b beta divided by m. So I just replace z2 value wherever z2 virtual number is there, virtual number of teeth, I have replaced with another equation in terms of d. Why I have replaced this in terms of d, this formula? Because the pitch dia is given in the question, number of teeth is not given in the question, so I should take it in terms of d. So I have converted this, I have just taken this, I cross multiplied, I have taken this value wherever I found z2 value, okay, in this question value. So I just replaced it with this formula. So I got some substitution. As after substitution solving this, I will get this y2 value is equal to 0.124 minus 1.207 into 10 to the power minus 3 into m. So this y term I am going to substitute in this Lewis form factor, sorry, tangential Lewis equation. Okay, after solving this, I will get this equation. So equation 1, equation 2. So is as usual step. When you equate this equation 2 and equation 1, we'll get this. We'll get RHS. We'll get two values. Sorry, one is lesser value, another is a higher value. So we, as per the problem what we discussed in the last stage, as I explained, always we'll take it with a smaller value. Okay, then we consider this value and we'll stop there, that particle. Next, if you go to Z step number 3, here we have the formula Z1 is equal to D1 into cos beta divided by Mn. So since the D1 value is given in the question, we know the helix angle beta and M value here. M value for standard, if you take that standard value, okay, and if you substitute, you will get the number of teeth. This is the actual number of teeth. This is the actual number of teeth. Whatever you got it in, you taken in the previous step, this is the assumption value. So in this question, Lewis tangential tooth load, wherever there is a y factor, in this y factor the z term will be replaced with d term in terms of d. So then you will get this equation. After solving this, we will get, so this z1 z2 all we found out. Next, remaining procedures are common, remaining steps are common, no need to worry about, there is nothing changes in the remaining step. Dimensions you need to find out, remaining all the things as usual you can calculate. There's one of the important thing you need to identify. These are the only differences you can find out in this. Next, in some question they will ask you design the gear. The design should be compact. Then the material whichever you're going to select, they will not mention the material type, they will not give any other data like z1 z2 all these things. Then you should assume stronger material, you should not take the what do you call lighter material or something like that. Where in the, if you take the data handbook list, in that which is the whichever the value of stronger material is there, then you have to choose, because any of the design should be compact, you should go for stronger material. Then there is a importance of this, there is the importance of this word sentence, right? This for the important, this is the important tips in the helical gear or spur gear. Please note this. Okay, thank you.